discuss numerical based on the conservation of linear momentum. And the question is a neutron having a mass of 1.67 into 10 raised to the power minus 27 kg and is moving at 10 raised to the power 8 meter per second collide with a neutron at rest and sticks to it. Neutron sticks to deuteron. So the mass of a neutron is 1.67 into 10 raised to the power minus 27 kg. So let m1 is the mass of neutron, which is 1.67 into 10 raised to the power minus 27 kg. And it is moving with a speed of 10 raised to the power 8 meter per second. So u1 is 10 raised to the power 8 meter per second. And a deuteron, the mass of deuteron is twice that of the mass of neutron. So m2 is 3.34 into 10 raised to the power minus 27 kg, and deuteron is at rest. So u2 is 0. If the mass of the deuteron is this, find the speed of its combination. We have to find the speed of the combination. When they stick to each other, then their total mass becomes m1 plus m2, and the total mass is moving with which velocity, which we have to calculate it. So from the conservation of linear momentum, total momentum before collision is equals to total momentum after collision. So m1 u1 plus m2 u2 is equals to, after collision they stick together. So their mass will be combined into mass into velocity. Velocity we have supposed capital V. So put all these values. m1 is 1.67 into 10 raised to the power minus 27. u1 is 10 raised to the power 8 plus m2 is 3 into 3.34 into 10 raised to the power minus 27 into 0, because deuteron is at rest. And sum of these masses 1.67 into 10 raised to the power minus 27 plus 3.34 into 10 raised to the power minus 27 into V. So this becomes 1.67 into 10 raised to the power minus 19. Minus 27 plus 8 minus 19. This whole becomes 0, and these two be added. This becomes 5.01 into 10 raised to the power minus 27 into V. So the value of V is 1.67 into 10 raised to the power minus 19 upon 5.01 into 10 raised to the power minus 27. So 1.67 upon 5.01 into 10 raised to the power minus 19 plus 27, it becomes 10 raised to the power 8. And after solving this, we get the value of 0.33 into 10 raised to the power 8. This we get 0.33 into 10 raised to the power 8 meter per second. So their combined mass, neutron and deuteron, both are moving with a velocity of 0.33 into 10 raised to the power 8 meter per second. Then question number 2. A 3 kg shell is flying at 48 meter per second. A 3 kg shell is flying at 48 meter per second. Mass and velocity of the shell is given. When it explodes, when it explodes, when it explodes, it's one part of 18 kg stop. It's one part of 18 kg stops. One part of 18 kg stops while the remaining part flies on. While the remaining part flies on. So we have to find the velocity of latter. Find the velocity of latter. Means we have to calculate the velocity of the other part. So let mass of the cell is represented by capital M. So mass of the shell is 3 kg and its speed is represented by U, which is 48 meter per second. U is 48 meter per second. When it explodes, it's one part, which is 18 kg. So M1 is 18 kg and one part of 18 kg stops. Its velocity V1 is 0 and the mass of the other part. So total mass is 30 kg. A mass of 30 kg. M is 30 kg. So mass of the other part, 30 minus 18, we get 12 kg and we have to find its velocity. So let the velocity of the other part, M2, is V2. So we use the conservation of linear momentum. So total momentum before explosion equals to total momentum after explosion. So before explosion, the mass of the shell was 30 kg and its speed was 48. So 30 into 48, mass of the first part is 18 kg, its velocity is 0. Mass of the other part is 12 kg and its velocity we have to calculate. So 30 into 48 is equals to 12 into V2 and we get the value of V2 equals to 30 into 48 upon 12. Means the other part will move with a velocity of 120 meters per second. Other part of the mass, which is 18 kg, moves with a velocity of 120 meters per second. Now the third question is, a body of mass 1 kg initially at rest, a body of mass 3 kg initially at rest. A body of mass 3 kg, a body of mass 1 kg initially at rest explodes and breaks into 3 segments. Explodes and breaks into 3 segments. Explodes and breaks into 3 segments of masses in the ratio of masses in the ratio 1:1:3. 1:1:3, the two pieces of equal mass fly off. The two pieces of equal mass the two pieces of equal mass which have the ratio 1:1 fly off perpendicular to each other. Fly off perpendicular to each other with a speed of 30 meters per second. The speed of the two equal masses is given 30 meters per second and they fly off in perpendicular direction with a speed of 30 meters per second each. So what is the velocity of the heavier fragment? What is the velocity of the heavier fragment? We have to calculate the velocity of the heavier fragment, and ratio of the mass is given 1:1:3. So we calculate first the mass of each fragment, and the diagram is a body of mass 1 kg initially at rest explodes and breaks into 3 segments of masses. First segment having mass m1 flies at a velocity of v1, and other segment fly off in a direction 90 degree to the first. This is mass M2 which fly with a speed of V2. They are perpendicular to each other. Means this angle is 45 degree and this angle is also 45 degree. And the third mass M3 moves in the direction opposite to. This is the heavier mass. So this is represented by M3 and its velocity is V3. So we have to calculate the velocity of the heavier mass. So firstly we calculate the mass of each fragment. We have given in the ratio. So x plus 3x is equals to 1 kg. This implies 5x equals to 1 and x equals to 0.2 kg. X equals to 0.2. The value of x is 0.2. Now calculate mass M1 which is x means 0.2. Mass M2 is x which is also 0.2. And mass M3. This is the ratio 3x. So 3 multiplied by 0.2 we get 0.6. So there be component of velocity V1 and V2 because they are inclined at an angle of 45 degree with the x-axis. So there must be component of V1. Component of V1 in horizontal direction is V1 cos 45 degree and component of V2 in horizontal direction is V2 cos 45 degree. So we use the conservation of linear momentum M3 into V3. This is in opposite direction of V1 and V2. So M3 into V3 equals to M1 into V1 cos 45 degree plus M2 into V2 cos 45 degree. M3 is 0.6, so 0.6 V3. M1 is 0.2. Velocity V1 is 30 meter per second. So 30 cos 45 degree and plus mass M2 is also 0.2 into 30 cos 45 degree. This becomes 0.6 V3 equals to 2 into 0.2 into 30. The value of cos 45 degree is 1 by root 2. 1 by root 2 means 0.707 and V3 equals to 2 into 0.2 into 30 into 0.707 upon 0.6. And after solving, we get 14.14 meter per second. 14.14 meter per second. So these are the numericals based on conservation of linear momentum. Now the next topic which we discuss, equilibrium of concurrent forces. Equilibrium of concurrent forces. Equilibrium of concurrent forces. So forces acting at the same point on a body. Forces acting at the same point. Forces acting at the same point on a body are called concurrent forces. Are called concurrent forces. Forces acting at the same point on a body are called concurrent forces. When a number of forces acts on a body at the same point, when a number of forces acts on a body at the same point, when a number of forces acts on a body at the same point and the net unbalanced force is zero, and the net unbalanced force is zero, the body will continue in its state of rest. The body will continue in its state of rest or of uniform motion. If the resultant of all the forces, all the unbalanced forces acting on a body is zero, it means the body will continue in its state of rest or uniform motion along a straight line. Along a straight line. And are said to be in equilibrium. And are said to be in equilibrium. So forces acting at the same point, forces acting at the same point on a body are called concurrent forces. And when the number of forces acts on a body at the same point and the net unbalanced force is zero, sum of all the forces acting on a body is zero, net force is zero, then body will continue its state of rest or of uniform motion along a straight line, and the body is said to be in equilibrium. Suppose there are two forces acting at a point. There are three forces acting at a point O. F1, F2 and F3. These are the three forces acting at a single point O. Then the resultant of force F1 and F2. Resultant of the force F1 and F2 will be F1 vector plus F2 vector. So the direction of F1 plus F2 is directly opposite to the force F3. So we can write that F3 vector is equals to minus of F1 vector plus F2 vector. And when that comes on left side, they becomes positive. So F1 vector plus F2 vector plus F3 vector equals to 0. This is the condition of equilibrium of three concurrent forces. Conditions of equilibrium of three concurrent forces. So the force F1 acts in the direction. This is the force F1. This is the force F2. And force F3 acts in a direction like F3. So all these three forces along the same direction. So their resultant will be 0. F1 plus F2 plus F3. F1 plus F3 plus F2 equals to 0. So they are called concurrent forces, and this is the condition for equilibrium of the concurrent forces. So condition for equilibrium of a number of forces acting at the same point is the vector sum. Condition for equilibrium of forces acting at the same point is the vector sum of all the forces. And in equilibrium, the vector sum of all the forces must be equals to 0, means F1 plus F2 plus F3 vector. They are all equals to 0. Their sum be 0. And forces acting at the same point on a body are called concurrent forces. And when number of forces acts on a body at the same point, and the unbalanced force, net unbalanced force is 0, then the body will continue in a state of rest or in a state of uniform motion in a straight line, and the condition is said to be in equilibrium.